Place your card on the scanner.
So I have an RFID and I use that to scan into the system. The system has two states. One is when I'm out of the system, when I'm in the system. So to go into the system.
You are authorized.
So now I'm authorized to use the system. We have two sensors here. One is the PIR and the other one is a ping. The PIR sensor is used to detect motion within the cubicle. The PIR will be used in both states, inside and outside, whether you're logged in or you're logged out of the system. When you're logged out of the system, the PIR will make sure that there's no detection within the cubicle. And when you're into the system, it'll make sure the person is actually there working. Similarly to the ping, it measures the distance from the person. We set it as 100 centimeters, so usually when a person is working in front of it, the ping would measure my face, and it would say that, yes, I'm within a certain range of the cubicle. Suppose I have some work away from the system now. I'm already logged in, so to properly lock the system, I would scan my RFID again and then leave.
System locked.
So now my friend Ansh will try to take something from my system. He does not have permission to access it. He does not have my RFID.
Intruder detected.
So basically what happened was the PIR sensor detected that there was a person
Intruder
there.
detected.
And the webcam will take a picture of it. So we also implemented an additional feature that includes lighting. The idea is we have a digital light sensor which would measure the surrounding light, and based on that, based on inverse proportions, the LED lights would change their brightness. So right now the brightness outside is pretty decent. We have lights on, so these LEDs will be at a small amount of brightness. Suppose now if there are no lights, the LEDs will become brighter. So that was that system. Alright, so this is the accelerometer cum gyroscope implementation that we use to measure the posture of a person. The Arduino board would be connected to the person's arm, and the device, the actual MPU 9150, will be connected behind a person's shirt, fastened with a magnet. So what we're going to do is that when we run the program, if we look at the middle value here, that's the required value, and that's called the pitch, the inclination of a person. So right now I am doing okay. When I'm actually perfectly straight, the values will be around 55. However, when I start to slouch forward, which is that this the accelerometer will bend forward, and the values will come out to be something pretty drastic, around 70 degrees. And now that is not something we want. So what happens is a timer that we can see here, this 7, 8, a timer happens, and if within that time, if I'm not able to correct myself, a vibration motor will vibrate, telling me that, hey, I need to correct my posture. The same idea can be implemented if I'm leaning backwards. So if I'm leaning backwards too much, relaxing a bit too much, and not actually using a proper posture when I'm using the cubicle, we can see values that are, approaching 45 degrees, 47. So because we kept the lower limit as 45 degrees, if I go below 45, then it will give me a buzzer telling me that, I have to get back to proper position.
This is the implementation of the concentration reminder. The webcam will constantly measure whether I am looking at the screen or not using image processing. And as you can see on the right, the Mosquito client will publish the data in real time whether I am looking at the screen or not. This data can be used by anyone who wants to know the status of the student. Like for example, the smart classroom people, where the teacher can use the data for measuring the concentration of the students. Now I'll look away from the screen, and the reminder will start measuring the time counter, after which it will remind me to focus again. For example, 6 seconds.
You need to focus.